Hi. Okay, so we're going to continue the last part for 1.1, okay, about mass spectrum and the calculation involving mass spectrum. Alright, so now we have two isotopes for Na, okay. The first one is Na23 and the second one is Na24. But actually, Na, the sodium atom, have more isotope than this, okay, such as Na25 and Na26. But for today's lesson, I'm going to take only two isotopes for Na. Alright, so these isotopes have different mass. If you can see, the first isotope, the mass for the first isotope is 23, and the mass for the second isotope is 24. But if you look at the periodic table, okay, this is the periodic table, and this is the sodium atom. The mass given in the periodic table is 22.99 actually. But where does this value come from? Okay, if Na have a lot of isotope. So to answer this question, okay, we need to look at the mass spectrometer. Okay, so this is a mass spectrometer. Okay, so mass spectrometer is a device, okay, to measure the mass of each isotope for element. Okay, so for example, we have a sample of Na. Okay, this is a sample of Na that consists a lot of isotope. So inside this sample, dia ada Na24, Na23, okay, Na25, and a lot of isotope for Na. Okay, when we put the sample of sodium inside mass spectrometer, this device will interpret this isotope and give us a data in terms of mass spectrum. Okay, so this is the diagram for mass spectrum. Okay, so this is diagram for mass spectrum. Okay, which is the y-axis, okay, indicate relative abundance. Okay, and the x-axis indicate M over E, which is mass of each isotope. Okay, and the abundant ni maksud dia apa? Abundant ni dia punya kebarangkalian kewujudan ni lah. Okay, sometimes the abundant, okay, also said in term of percentage. Okay, dia tak tulis relative abundant, tapi dia gantikan y-axis ni dengan percentage. Sometimes dia gonna say ratio. Okay, and sometimes they say abundant as intensity. Okay, so all these things, okay, are referred to relative abundance. They are the same thing. Okay, and for example, if we had a sodium sample, this is only for example, okay, the data given, okay, we come out something like this, okay, and each one of these peak indicate how many isotope that sodium have. So for example, if they indicate 4 peak, okay, which means sodium will have 4 isotope. Okay, if they indicate, they put about 2 peak, which means that thing have 2 isotope. Alright, and okay, down here the x-axis will indicate the mass for each isotope. For example, we have sodium. Okay, this is for sodium. Okay, the first one is 24. The second one is 23. The third one is 25. And the fourth one is 26, for example. So from this mass spectrum, we can see that the most abundant, okay, yang paling banyak wujud, okay, in this world adalah sodium 25. This is only for example, sodium 25 because it have highest abundant ataupun highest ratio, highest percentage, highest intensity. Okay, and the lowest abundant of isotope Na is isotope Na23. Okay, this is how we have a look the mass spectrum. Okay, so from the mass spectrum, we can see the abundance of each isotope and which isotope is the most, as has the highest intensity. Okay, highest ratio. Okay, can you get it? Alright, okay, so from the previous example, I give you the mass spectrum for sodium, right? And the mass of each isotope, okay, I put in the whole number. Okay, 23, 24, 25, and 26. But when you come across the question, they might give you the mass in terms of decimal point. They might give you something like this, 23.9421, 24.5674, something like that. So if they give you something like this, for the calculation, you need to take all this value. Alright? Okay, so now, okay, for example, for sodium, we have 4 isotopes based on the mass spectrum. Okay, so from the 4 isotopes, they have 4 different masses for each isotope. So to get only one mass for sodium, in order to put inside the periodic table, we need to calculate the average atomic mass of sodium. Okay, so how can we get the mass of 22.99? The previous one, we look at the periodic table, right? So we need to calculate the average atomic mass of sodium. Okay, so the formula for average atomic mass is sum of Qi Mi over sum of Qi. So what is Q, what is M? Okay, so the Qi is the abundant. Okay, Mi is the mass of isotope. Okay, so you need to time sum of abundant times mass of each isotope over sum of abundant. And the unit for average atomic mass is mu, or you can say AMU. Okay, they got unit. Alright. Now, in order to put inside the periodic table, okay, we need to calculate their relative, because every single element we need to compare with carbon 12 before we put inside periodic table, the data inside the periodic table. So when you get the average atomic mass, okay, you need to calculate the relative atomic mass, which is the symbol of relative atomic mass is AR, and the formula is average atomic mass, which is they have unit U, over 1 over 12 times mass of carbon 12, okay, which is 12 U. Okay, so when we cancel out this U, relative atomic mass will have no unit. Okay, can you get it? Okay, so when you get the question, look at carefully whether they ask you average atomic mass or relative atomic mass. If they ask you average atomic mass, you need to use this formula. Okay, make sure you write down the formula. Every single time you should write down the formula, and average atomic mass has unit. Okay, but if they ask you to calculate relative atomic mass, first step, you need to calculate the average atomic mass first. Okay, first kalau dia minta relative, first step you kena calculate average. Okay, and then second step baru you calculate the relative atomic mass. And for relative atomic mass, there are no unit. Okay, and if they ask you to calculate the relative molecular mass, or the symbol is MR, how is it? Okay, relative molecular mass, sorry. Okay, you just sum up all the average atomic mass. Sorry, boleh? You just add it up, not average, I'm sorry. You just add up all the relative atomic mass. Okay, MR is equal to sum of AR. Okay, for example, they ask you what is the relative atomic mass for H2O. So first step you need to get what is the relative atomic mass untuk hydrogen, and what is the relative atomic mass for oxygen, and the relative molecular mass is just adding up these two. Alright, can you get it?